everyone, this is me, I'm Amber, and I am the 10th grader that will be explaining what the periodic table is and what the trends are on the periodic table. Now, here up is a picture of the periodic table, and yes, this is my honors project for my honors chemistry class, and I know you guys might be thinking, oh, why are you going for something so simple? Well, for one thing, this table is one of the most important tables you will ever feast your eyes upon. This table has changed chemistry as it is, and you will be laying your eyes upon this as you are learning about the periodic table throughout chemistry and maybe even throughout your job, depending on what kind of field of science, or even if you are going to science, you may need to refer to this graph. Now, let's move on. So, what you should know before going into this head forward first and having no clue what's going on by the end of this video. I know, I love this title of this slide too. You need to know what an atom is. That is a very important key concept, and it is one of the things that you need to know about chemistry even before you start about it. What the parts of an atom is, you need to know what are some of the parts right here. Let me see if I can get my little pen here. You need to know what these things are, this big thing is, and what are in here. So you need to want to go ahead, and you need to know what elements are. So let's move on. Anyhow, you may want to have handy a periodic table, which is exampled right here, pen and paper, and markers of different colors, because you need a little bit of color in your life to keep your focus and activated on your assignments and to color in the pictures you might be drawing as you're watching this video. Am I right? Anyhow, let's move on. This should be what we will be talking about today, or what you will be learning. We will be doing a quick review. First off, the history of the periodic table, because I like to know what happens to form this, and I have a lot of people names that I cannot pronounce, and I have a paper here showing me how to pronounce it, and I have a funny feeling I'm still going to butcher it, so go ahead and apologize. What the periodic table is, how to read a periodic table, and the trends in a periodic table, and all of which we will get into. So let's go ahead and make a smiley face, because we need to be happy through this. Anyhow, let's see, this is our quick review, one of our first subjects right here. So we will be talking about what atoms are. They are the small unit which matter can be divided into. The atom was discovered by J.J. Thomson in 1897, and atoms have three different parts: the proton, electrons, and neutrons. Protons and nucleus are in the center, while the electrons circle around the atom. Protons and neutrons actually makes the big center part. Pretty sure that's called the nucleus. So as you can tell, here we are. Yep, it was called the nucleus, and we have a lovely picture that I found off of Google, and it shows us what are the little parts where the neutron, proton, and electrons are. You can tell electrons are negative, protons are positive, and neutrons, as their name says, they are neutral. The history of the periodic table. So before we dive in head first, there is going to be a lot of talking. There is going to be a lot of names that I am not going to be able to pronounce, because these people are old, or they are from a different country other than America or America. So I had to take a quick sip of water, because this is going to need a lot of talking here. So before we get started, of course, I need to show you my periodic table of mustaches and beard, just to make me feel a lot more happy about talking about all these names that I won't be able to pronounce. Anyhow, here we go. Let's see. Now we need to know the history of the very important table, also known as a periodic table. Yes, I love my titles of my slides. So the very first ever periodic table was made by A.E. Beeger de Chanchu. I'm already screwing up his name. He is French, so excuse my French. Let's just call him Beeger for now. This table was a list of elements on a cylinder by increasing atomic weights. In 1863, John Newlands wrote a paper and classified the known elements at the time, 56, into 11 groups by similar physical properties. By 1864, he made another table and the laws of octaves. We won't be going too deep into them, because I don't think I understand them fully enough to tell you guys what they are. And you aren't that far yet. You can ask your teacher, a lovely teacher, or a lovely parent, family member, or a lovely older sibling, or the internet about what these are, and we'll get more in depth and then tell your teacher how smart you are. Yeah. So this is his Beaker's table here. As you can tell, it is more like a cylinder here going up slowly, and you can kind of see some of the elements we kind of see on our table already. I think I saw one, yep, right here. Here is not hydrogen. This is hydrogen right here. This is oxygen, I'm pretty sure. Anyhow, going on, we will be seeing John Newland's periodic table. And it's a lot more simpler to read here. As you can see, it is in groups here, going down columns. And it is really nice and easier to read, for me anyhow. Anyhow, who is the father of the table? This is turning into a TV show about figuring out who's your kid, guys. Anyhow, a lot of people and many scientists and chemists fight over who the true periodic table of the father is. And well, many also says that it's actually Russian. Excuse my Russian here. Dmitry Mendela. I think I said his name right. And then not many people pay attention to the German Lothar Meyer. I'm sorry. I can't read sometimes. And yeah, let's learn a little bit more about him. So, Lothar Meyer, he published a textbook in 1864 that had abbreviated versions of the current table at the time. Half of the known elements at the time were in or atomic rate in the periodic valence changes. So as you can tell here, you can see how it changes and all that, and how you can already see some of the elements we see. So AU, I'm pretty sure that's gold. One, I'm pretty sure, don't take me out on that one though. So anyhow, Dmitry Mendel. Most of the people in the science community, like I said before, believes this is the guy who created the periodic table, and he had made a lot, and he has a lot more history that I could find than our young, grateful German friend Lothar Meyer. He was born to a really big family, and that was very harsh, and when his father passed away, his mother saw potential in him and rode him on horseback towards many colleges, and he was accepted at one at St. Petersburg Institute. Now, after he left the school, he was a teacher for a little while, I believe, and then he started to look more into chemistry, and then he started to write The Principle of Chemistry. As you can tell, this is the title of his book. A little bit more about him, because I couldn't fit it on one page. In this book, he organized the elements in terms of family, which showed the same properties. He also organized them with alkaline metals and other type of metals we will be soon learning about, so stay tuned for that. Then he ran into a problem. To fix this, he labeled cards with element symbol, atomic weight, and the table slowly started to take shape. So, this is his table, and you can already tell this table looks almost familiar to the one that we have today. Anyhow, let's see. Anyhow, what is the periodic table? Now, it is not what we just saw on the last screen. It is not a table with a lot of periods on it. Sadly, it's not that simple. This table may not seem important, like I said in the beginning of this video. It is one of the biggest references to chemistry. This table organizes all the elements in a way that it makes it so much easier for us all to read. So here are periods and groups. They are very important to us, and these are very interesting ways to understand periodic table and make it very easy. Periods, as you can see here, go side to side. So they go like this. If you want to go ahead and write that on your paper saying period, I can't spell I don't have a pen, so I'm just using my mouse. As you can tell, I'm not very good with writing my mouse. And the number of electrons increase as you go down a period. This is also known as a trend that is on a periodic table. So I recommend you to remember this and even write that down. Anyhow, up and down are not graphs, but groups. Here we are, right here. They have identical valence electron configurations. So they are identical, kind of, if you get what I'm saying. Different types of metals on the periodic table. Now we can alkaline metals. They're very reactive, which means they will react with almost anything you put them with. They're malleable. That means they're very easy to move. I'm sorry, cannot think today. They're very good conductors. That means they can conduct electricity very well. They can explode when they they can explode when they're exposed to water. I know, a very lovely tongue tie, so be careful when you're with that near water, and they only have one loosely bound valence electron. Alkaline earth metals, they have low electron. Oh my goodness, I'm sorry. I lost my train of thought there. And they have electronegativity. Two electrons in the outer shell, smaller atomic radii than alkaline metals, and not as reactive as the other ones. So now, let's go ahead and kind of mark here. Now I have a graph that is kind of cheating, telling me where everything kind of is, but it will be easier on me and you because I don't want to make it too much time. So right here is our alkaline metals, and our alkaline earth is right here. Isn't that amazing? Go ahead and mark that down. That's why I say you should have markers or something, so you can mark down what kind of they are and then write it down on the side. So we have more element types. What? Transition metals are fairly reactive and malleable. They have high melting and boiling points, and electrical con, oh my goodness, I'm sorry, I cannot English sometimes. Conductivity? Yes, there we go. Halogens, very high electronegativity, 7 valence electron, and highly reactive alkaline earth metal. So these two guys, this alkaline and these guys, they don't get along too good. So I recommend you don't let them be friends or even try, because they will explode most likely on you. So let's figure out where they are. The transition metals are all in this yellow area right here. This yellow area. So they're like in the middle of the group. They're like in the little middle. They're middle friend. They're the middle wheel and all that sad kind of stuff. Halogens are right here, right beside our lovely noble gases. Look at them lovely noble gases. The lovely nice shade of purple, aren't they? Now we have the lanthanoids and the noble gases. Lanthanoids are silvery white metals that tarnish when exposed to air. They have high melting and boiling points, and they are very reactive. Noble gases, which are my personal favorite, they are fairly non-reactive. They probably won't react if you put them next to something. They have almost or complete valence shells. They are very low electronegativity, low boiling points, and all the gases are at room temperature. These noble gases were actually very hard to figure out in the past days because you couldn't see them. They're gases. Anyhow, we're going to figure out who they are. We already know the noble gases all the way at the end. They're a little bit shy, aren't they? And the lanthanoids, they are right there. Metalloids, gases, and nonmetals. So metals solid at room temperature except for mercury. Mercury just had to stand out, guys. Clap for him, just Mercury. Everyone should strive to be Mercury. Metalloid possesses characteristics of metal and nonmetals, and nonmetals are brittle solids that gain electrons easily. So now we'll be looking at the trends in the periodic table. Maybe these periodic tables just love to wear them some polka dot dresses here, like one of them that I'm designing right here, or a nice shirt right here that I'm designing. See, I am a very good designer. I think a lot of people will buy my clothing here. This is my triangle dress and my weird peacock shirt right here. Totally buy that. Anyhow, trends in the periodic table. The periodic table has certain trends in it and is hidden in it, and if you know who they are and where they are and what to look for, it will make your life in chemistry so, I repeat, so much better. Now going back to our friend here, our Mr. Russian guy, he made a periodic table, and if you remember correctly, he made it to where it was certain things were raising and increasing. So, trend number 1, how atomic radius can increase. The atomic radius is a distance from the atomic nucleus to our most stable electron orbit. This is like a circle on the radius, but since electrons are always moving, it's very hard to pinpoint the exact radius. So this makes it so much easier to figure out what the atomic radius is. So as you move down a group, atomic radius increases. The reason this happens is because the number of energy levels increase as you move down, as the number of the electrons, meaning that it gets further from the nucleus than the last. So that means that since it's further, the radius is more. As you move across the period from left to right, it decreases the atomic radius. Electrons are added to the same energy levels as you go across. At the same time, protons are also being added to the nucleus. This creates a stronger force of attraction, pulling the electron closer to the nucleus. Trend number 2, guys. We have first ionizing ionization energy. First ionization energy is the energy that removes the most loosely held electron in the outermost shell from a neutral atom in its ground state. That was a mouthful, so I'm going to get me a sip of water. Oh, that's a nice sip of water. As you move down a group, the first ionization decreases. This is because the electrons are further away from the nucleus. And if you remember that in the last time, as you go down a group, you get more of a radius, atomic radius. So this makes sense. So that means it will be easier to move the outermost electron. As you move across a period, the first ionization increases. The atomic radius decreases, the atom is smaller, and therefore the electrons are closer, making it hard to remove the electron. Trend number 3, coming right up, walking down that catwalk, doing his stuff, electronegativity. Whew, I can barely say that one. Is a measure of the tendency of an atom to attract a bonding pair of electrons. This depends on the number of protons in the nucleus, the distance of the electrons from the nucleus, and the amount of screening by the inner electrons. Yes, it is a lot to take in, and it is a lot for me to take in. I can barely get it out my mouth in one whole sentence. Woo! As you go across the period left to right, electronegativity increases. As you go across the period, the number of charges on the nucleus increases, and the attraction of the bonding electron more strongly. As you go down a group, the electronegativity decreases. This is because the bonding pair of electrons are getting more and more distant from the nucleus as you go down a group. Anyhow, guys, there are many more trends in the periodic table. There's just so many out there that you can find, and it takes a lot more. Like, there can be equations to figure out. So x equals x. That's the closest I can think of an equation. There are many equations that you will need to figure it out, and it'll get so in depth that this video can go on for hours. And I don't want to make that. You guys are just beginning to learn what these are, and I don't want to explain it and they get them wrong, and they think one thing, teach you guys one thing, and make you guys fail that very important chemistry test. So you will learn more as you go through your school education and your teacher teaches you, or you can even ask your teacher to teach you more about trends, maybe during recess, or even go on the internet to look them up. Anyhow, guys, summary. We figured out the history of the periodic table can date back to 1862. We figured there are groups and periods on a periodic table, and there are many trends in the table. I will be trying to put timestamps to where they were, but if they are not there, I am so sorry I couldn't figure it out. But if you guys in the comments can hopefully help and put down timestamp down for me if I was not able to figure out, that would be very thankful and grateful. The websites that I use, of course, I have to use websites because I do not want to mess up anything. So as you can see some of my websites here, you guys can gladly search them up, and all the pictures that I found were with Google search. Anyhow, guys, thank you guys so much for watching. I want to try to draw myself a heart here. I'm not very good at art here. Yeah, all that matters is love, right? Yeah, just make a little nice smiley face. Yay! You made it through my video. Thumbs up. Yeah, that's a thumbs up right there. Woo! Guys made it. You do a good job making hundreds in school. Yeah, thank you guys so much.